Hi, welcome back. Before we begin to talk about the application of the derivative and trying to find the derivative of a higher power function, one thing I want to take a look at is our old friend Pascal's triangle. Right here we have what's called a binomial. We have two terms represented to some power. Now if I were to say a plus b, b to the first power, we all know that that would be a plus b. And if we did a plus b squared, most of us could probably figure that right out twice and distribute. You would get a squared plus 2ab plus b squared. But what if I want to do something like a plus b cubed? How many of you have that memorized? What if I want to do something like a plus b to the fifth or to the sixth? How can we, instead of writing it out 6 times and multiplying it, is there another way we can write this out? And the answer is yes. We have what's called Pascal's triangle, and you might remember this from your geometry course as well. And Pascal's triangle is a self-generating triangle where along all the lengths here we have ones, and as we go into the middle we're going to add these two together and get 2. So we get 1, 1 here, and of course this will be 3 and 3, and if I keep going I will get 1. This becomes 4, add the 2 above it, 6, the 2 above it, 4, 1, and I can keep going. 5, 10, add the 2 above it, 10, 5, 1, and I can keep going. Well, the beauty of Pascal's triangle is what it gives us in terms of our of our binomial. For example, the first one here, this would be considered a plus b to the 0 because we know anything to the 0 power is just 1. This 1, 1 here, well, that would be a plus b, of course, to the first, which is a plus b. Over here, this is our a plus b squared, which is going to give us our a squared plus 2ab plus b squared right there. So if you notice, what these numbers are going to give us are our coefficients, 1, 2, 1. And we're going to talk about how we can generate this. So right here, this could be considered a plus b to the third. This would be a plus b to the fourth, a plus b to the fifth, and so on and so forth. So how do we apply this? Well, let's say we want to do a plus b cubed. First, when I expand it using my Pascal's triangle, there's my a plus b cubed. This is going to become 1, 3, 3, 1. My coefficients. I know I spread them out really weird. So, and next, what I'm going to give is I'm going to have every term multiply them together. A times b. It comes from distributing. Everything gets an a and a b multiplied together. AB, 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 and AB. The next part is a little more tricky for us. The degree here says that every single one of these terms has to add up to a degree of 3. For example, this AB, if I add up their powers, has to be 3. So this could become 3, 0. I start with 3 and 0. Because we know, like when we expand it, it's really just a squared. Then we get to the ABs. So and then I just work down. This will become 2, 1, 1, 2, 0, 3, like so forth. And because it's addition, a plus, everything is going to be positive. If it was subtraction, we would alternate. It would be positive, negative, positive, negative. So we would get this, a cubed plus 3a squared b plus 3ab squared plus b cubed. And that would be the distribution of a plus b cubed. And you can try with all sorts of these, okay? So let's use this to help us find the derivative of x cubed. So this is our continuation. We want to find the derivative of x cubed. So we know our rule. It's the limit, the limit as h goes to 0. Remember, it's that f of x plus h, right? If we go up here, f of x plus h. So everywhere there's an x, I'm going to put in x plus h. So it's x plus h cubed minus f of x, the original function, x cubed all over h. Next, this is my derivative, f prime of x equals the limit. Don't forget to write that limit every time Now we just talked about this, so if we look back at our little note that we just did for us, right over here, there it is. This is telling me what my coefficients are going to be. So we're using x and h instead of a's and b's. So we would get x cubed plus 3x squared h plus 3x h squared plus h cubed, and then minus your original function, x cubed over h. You get really good at this. Again, anything that just does not have an h in it cancels, and everything that is left has an h, so I can factor out that h. So I would get the limit as h goes to 0. So factor out the h on top, h 3x squared plus 3xh plus h squared over h. H's cancel, and again, just do a quick algebra here. All h's go to 0, so it's all just 0, and I'm left with 3x squared. So therefore, our derivative is 3x squared. Remember, this is a derivative, not the slope itself, but this will find the slope at any given point. This only finds slope, and that's it. That's all its job. Okay, we talked about that. Next, we want to write the equation of a tangent line at x equals 1. Well, we also talked about this. So the two things we need are, first, we need a point to get the point at x equals 1, and I'm going to use my f of x. Well, that's going to say f of 1 would equal 1 cubed, which is 1. So my point, which would just be 1, 1. Next, we have to find the slope at the point. That's f prime of 1. So that's 3 times 1 squared, using my slope that we just found. And that's going to give us 3. And there's our slope. Write the equation of our tangent line. Again, we're going to use the point slope. Y minus y1 equals m. X minus x1. Don't use this. Don't use y equals mx plus b. It takes too long, and you have to solve the things. It's nasty. Just plug it in. Y minus 1 equals my slope, 3, x minus 1. And there's our tangent line. Don't simplify it. Leave it alone. Leave it alone. Look at me. This is me saying to leave it alone. Okay, like a freshman walking down the hallway. Just leave it alone. Part C. Ready? Use the tangent line. Now, this is the big application. The great thing about the tangent line, now we can estimate values. For example, what if I were to say, find f of 1.1? Well, we would be looking at 1.1 cubed. And to do this without a calculator is pretty tough. But the tangent line allows us to estimate it. Okay? We can use a tangent line to estimate. It's not giving us the exact value, but we can estimate it. And I'll give you an idea. Ready? This is our graph of x cubed. Right here. At 1, we found this tangent line. Like so. We found this tangent line. We want to know what the value of the function would be at 1.1. We want to find that value. But I can't find this point. I can't find it. I don't know what it is. Okay, like I said, without a calculator it's kind of hard. But I can estimate the point on the tangent line. So what we're going to do is use our tangent line. We're going to let x equal 1.1, and I can plug it in. Y minus 1 equals 3. 1.1 minus 1. Y minus 1 equals, that just becomes 0.3. So y is about 1.3. That's my estimation right there. So, and you can even look at the graph and know that this is going to be an underestimate because it's actually below the actual value. We'll talk later on about how concavity tells us that as well. And if we want to find out how accurate this is, well, we can use a calculator. I'm going to use my calculator here. This is my Inspire right here. I have been inspired. Whoops. Get out of there. Doc B. Get out of there. And if I type in 1.1 to the third, wow, the actual value is 1.331. That's the actual value. If I minus my approximate, minus 1.3, look at that. We are 31 thousandths of a decimal off from the actual value. So even though it's not the actual value, 31 thousandths, that's pretty close to the actual answer. So we really like this tangent line approximation. All right, now here's how the AP will ask you this. the AP will say, okay, so you understand the derivative, you understand what it does. Then they'll say, okay, for the following, find f of x. So what they're telling you to do is that you have to recognize this is a derivative. Remember, this is f prime of x. So therefore, I can say what I want to find out, well, what is my original function here? And to do that, well, I could just recognize that this is just going to be, remember this, f of x plus h minus f of x? Well, what's the original function? Well, what is f of x? That's the second part, x squared. Pretty easy to do, right there. Pretty easy. What about number 5? It's a little bit tougher. What is our f of x going to be here? Well, again, they're using f of x plus h minus f of x on the top over h. That's what they're using. But this is the most important part. It's f of x. The outside is my function. And out here, notice, they're using sine. So my function is going to be sine. But I want f of x. Be careful, it's not going to be sine of pi. This is actually the slope itself. The that's going to be a number. I want the actual function. So I just replace that pi with x. And I get y, f of x equals sine of x. Alright, so those are the videos. I hope you guys enjoy them. Hope you guys learned a little bit. And I will see you guys later. Thank you. Bye-bye.